Hello students, welcome back to my channel again. So today we are going to learn about the highest common factor, that is nothing but HCF. So we have several methods of solving the HCF problems, but the first method is factor method. By the name itself you can understand by finding the factors we are going to find the HCF. So let us look at with an example and learn how to solve the HCF by using the factor method. So now we will find out the HCF of 5, 10 by using the factor method. So factor method is nothing but first you will find the factor of 5. That is 5 will be going in how many factors? So you will write it as 1 into 5. Yes, only 1 into 5. Other than this we don't have any other table to be the factor of 5. In the same way you can just write down the factor of 10. So factor of 10. So factor of 10 we have 1 into 10, 2 into 5. That's it. Again 5 into 2 and the table is repeating. So we are not going to write the repeated tables. So that's it. So now you can see what is the common factors in these two. We can just tell the common factors by looking at their factors. So common factors equals to 1, 5. So in this 1, 5, what is the highest common factor? That is nothing but the HCF. I mean the highest common factor, highest number or the greatest number. What is that number? It is obviously 5. So this is what the HCF means. So HCF of 5, 10 is 5. Second method of finding the HCF is nothing but the prime factorization method. So by using this prime factorization method, we are going to find the HCF of 16, 36. So we will just look how to solve that. The same simple process, the short division method is a method we are going to use in the prime factorization. That is nothing but, now we will check the 16 will be going in the least prime number. The least prime number is 2. So will the 16 go in 2 table? Yes. So you can do. If it's not going with the 2 table any number, you can go for the next prime number, that is 3, 5, 7. Like that you will be going on shifting the prime numbers. So here 2 is possible. So I am writing 2 8s are 16. Again 8 will go in 2 tables. So 2 4s are 8. Again 4 will go in again 2 tables. So 2 2s are again 2 will obviously go in one table. So till we get the 1, we are going to do this process. Now the same process we will apply for the next number, that is 36. So now 36 start doing with the 2. So 2 how many times it will go? It will go 18 times. And again start doing with 2. Again 9 times. Now will the 2 go in 9? No. So what we will do? We will shift the next prime number, that is 3. So 3 will go 3 times and again 3 will go 1 time. First we will write what is the prime factorization of 16, that is 2 into 2 into 2 into 2. And the prime factorization of 36, 2 into 2 into 3 into 3. Now you can just look at what are the common numbers in these all. So you can see that this 2 is common, 2 is common, again 2 is common, again 2 is common. Now the leftover numbers we don't have it in the same table, so you can just leave them. So now what we will do, you will write down as the common factors. So common factors equals 2. That is, here you have a multiplication symbol. So you will write down as 2 into 2 and therefore the HCF will become 2 into 2 is 4. So HCF of the 16 and 36 will give you 4 by using the prime factorization. Just remember one thing, by following any method, you need to get the same HCF. The HCF value will not change by changing the method. Example, the same prime factorization method. If you have to find the HCF of 3 numbers, you will have a slight changes in the process of finding the HCF. So that we will just look into. The starting process is same. You are going to find the prime factorization of 150, 175 and 250. So 150 is starting with 2. Yes, it will go. So how many times? 7 and 5, 75. Now 75 will not go in 2. So go with 3. So 3 will go how many times? 25 times, and now 5 5s are 25 and finally 5 1s are 5. So again 175, start with the 2 table? No. 3 table? Can we do with the 3 table? 7 plus 1, 8, 8 plus 5, 13, and 13 is not divisible by 3. So go with 5 table, and 5 table, yes, it is divisible. So 5 threes are, and I think 5s are. Yes, and now again 5 table, 5 sevens are, and now 7 ones are. Now go with the 250. 250 will be going in 2 table. How many times? 1 time, 2 time, and 1 is left, so 5 times. Now 125 will 5, 6, 7, 8, it will not go in 3 table also. Now we will go for 5 table. 5, how many times it will go? 2 times, and 5s are 25 times, and again 5 5s are, and 5 1s are. So now you got the prime factorization of 150, 175 and 125. So this is the third method, where that is called as continued division method. Is a method where you can find the HCF of 2 numbers, 3 numbers, 4 numbers, or any, like how many numbers ever they give you. This is like one of the most like easy method which you can follow if you have the very greatest number, like in a hundreds or more than 50, because like 36, 48, you can't write the factors. So prime factorization, yes, you can do it obviously, but continued division method is a method like which is very simple to do and the very less steps to be followed. So we will just look at how to solve by using the continued division method. So the HCF of whatever the numbers they have given you, here only 2, so very simple your problem will become. So what is the smallest number? You will write that as the division outside, and what is the greatest number? That you will write as the inside. So now tell me how many times the 36 table 48 you will be getting? Only 1 time. So just write down 1 time, subtract the value, it will be 12. Now you can see that the divisor is more than the remainder. So get this divisor inside, that is shift the divisor to the inside as the dividend. Now just your remainder will become your divisor. Now 12 table 36 will go 3 times, yes, so 3s are 36. Subtraction, you got a 0. So getting a 0, which number helped you? So the number helped is 12. So that is the HCF. Therefore, the HCF of 36, 48 is 12. Isn't this process so easy? You got like very simple than the remaining process? Yes. So as I told you, this method can also be used for 3 or 4 numbers. So how do you solve a 3 number HCF problem by using the continued division method? The process is same. You have to do the division, like, but here you have 3 numbers. So we can't do at a time the 3 number division. We only know how to do a 2 numbers division. So take up the first 2 numbers in 100 and 150. So first you find the HCF of 100, 150. Now tell me what will be the smallest number, that is 100. So write it outside, and 150 is inside. So how many times it will go? Obviously you can go only 1 time, and the remainder will become 50. Now as you all know that the divisor is more, bring this divisor inside. So after getting it inside, so how much is your value now? 52s are 100. So what helped you in getting the remainder 0? That is 50. So here, only for here the HCF is 50. For what? For 100 and 150. But you are left over with one more number also. Now you find the HCF of this number which you got by doing the 100 and 150, that is 50. So HCF of 50 and the leftover number, that is 200. You are going to find the HCF of these two. Now just tell me, so what is the smallest number? 50. So write it outside and take the largest number 200 inside. So just read out the 50 table. 51s are 50, 52s are 100, 53s are 150 and 54s are 200. So now just tell me now what helped you in getting 0 as a reminder? 50. So therefore, the HCF of all the 3 numbers is equals to 50. Don't ever stop your process here itself. We can't tell that you will get the same HCF at the ending also. So whenever they have given you 3 numbers, you will follow this method. And for example, if they have given you 4 numbers, you will do the HCF of 2 numbers and the last 2 numbers, and the HCF of those both will give you the final HCF of the 4 numbers. So these are the 3 methods of finding the highest common factor, that is HCF. I hope this video helped you in understanding the 3 different methods of solving the HCF problems. Thank you very much for watching this video.